The bovine corneal opacity and permeability assay, commonly referred to as the BCOP assay, is an in vitro eye irritation test method which uses living bovine corneal tissue to evaluate the potential ocular irritancy of chemicals and products. Types of injury caused by exposure to a compound are quantitatively measured by changes in opacity and permeability to fluorescein. In this video, we will walk through the tests step by step as described by the Organization for Economic Cooperation and Development Test Guideline number 437. The bovine eyes used in this assay are enucleated, collected, and prepared for transport at the abattoir. Once isolated, the eyes are immediately transferred to a container where they are fully immersed in cooled Hanks balanced salt solution, known as HBSS, on ice. The eyes are used as soon after isolation as possible, typically on the same day. The assay is begun as soon as the corneas are received into the facility. Upon receipt, the eyes are carefully examined for defects such as opacities, scratches, or neovascularization. The eye is firmly grasped and wet, drop-wise, with HBSS to help further visualize defects. Only corneas that are free of defects are acceptable and cut and mounted for use in the assay. Corneas with scratches, small areas of opacity, or blood spots would be discarded. After confirming the eye is acceptable for use, a small incision is made with a scalpel in the whole globe, leaving 2 to 3 millimeters of sclera. Care is taken to avoid damaging the cornea. Once the incision is made, the remainder of the cornea is removed with scissors. Hold the sclera with forceps and remove the other eye components by peeling them away from the endothelial side of the cornea. Avoid touching the cornea with the second set of forceps. The cornea is placed epithelial side down in a petri dish containing HBSS. Next, the isolated cornea is mounted in a specially designed corneal holder by placing the cornea epithelial side up onto the O-ring of the posterior chamber. The cornea is gently centered on the O-ring to reduce slippage and leaking. Take care not to move or stretch the cornea once it has been placed on the O-ring. The anterior chamber is then placed on top of the cornea, and both chamber pieces are joined together by tightening the 3 chamber screws. While tightening the chamber, apply gentle pressure to both pieces to reduce movement of the cornea. Now that the cornea is secured in the chamber, both the anterior and posterior chambers are filled to excess with pre-warmed Eagle's Minimum Essential Medium, or EMEM, without phenol red. The posterior chamber is filled first to ensure that the cornea keeps its normal curvature. The same steps are performed while filling the anterior chamber. Once both sides of the chamber are filled, the chamber holes will be plugged and the chambers are incubated at 32 degrees Celsius for at least 1 hour. Prior to use, the opacitometer is calibrated to ensure proper performance. It is calibrated with a series of calibrator chips, mimicking varying degrees of opacity. Following the 1-hour incubation, the media is removed from both sides of the chambers, starting with the anterior chamber first, using a blunt-tip syringe. Both sides of the chamber will again be refilled with fresh, pre-warmed EMEM without phenol red in a similar fashion as the initial media addition. Once the chambers are filled, a baseline opacity reading will be taken on each cornea. Any cornea that has an opacity score of greater than 7 opacity units or is observed to have macroscopic tissue damage will be excluded from use in the assay. This step serves as one of the quality control checks of the assay. Corneas that meet the assay acceptance criteria are assigned to a treatment group. Each treatment group consists of at least 3 corneas. The treatment groups will be dosed with either a test article, positive or negative control. The assay controls are treated concurrently with the test articles in this assay. The positive control chemical for each assay depends on whether it is a liquid or a solid protocol being performed. For liquid protocols, the suggested positive control is 100% ethanol. For the solid protocol, the positive control that is used is 20% imidazole. Now that the corneas have been assigned to a treatment group, the corneas are prepared for dosing. Since the dosing is different for liquid and solid test substances, both will be illustrated in this video. Before dosing for either liquids or solids, the media is removed from the anterior chamber, similar to the initial refeed step, and the chamber re-aspirated to remove any remaining medium. It is important to remove as much media as possible from the anterior chamber in order to reduce further dilution of the test article. Now that the chambers are prepared, Lindsay will demonstrate how to dose a liquid test article. Liquid test articles can be tested undiluted or for surfactants at a concentration of 10% in a solvent. When dosing most liquid test substances, the closed chamber method will be used. Some liquid test materials may be viscous, semisolids, creams, or waxes. In this case, they will be applied using a positive displacement pipette by the open chamber method, which Nathan will demonstrate during solid dosing. First, the chambers are tilted up, as shown, to avoid contact between the test chemical and the cornea, which could extend the exposure time beyond the appropriate interval. Lindsay is adding 750 microliters of the test chemical to each chamber through the holes in the top of the chamber. The holes in the chamber are sealed with the plugs. Once all corneas are dosed, the chambers are flipped into a horizontal position simultaneously to cover the corneas with the test article at the same time. The corneas are then placed back in the incubator and exposed to the liquid test material for 10 minutes. When dosing non-surfactant-based solids, they are typically tested as solutions or suspensions at 20% in either sodium chloride, distilled water, or another solvent. Solids are typically tested by direct application with a positive displacement pipette onto the corneal surface. This process is commonly referred to as open chamber dosing. After the media was removed from the anterior chamber, as mentioned earlier, the chamber holes are plugged and the chamber will be horizontally oriented for open chamber dosing. In the first step in open chamber dosing, Nathan removes the window locking ring and the glass window from the anterior chamber. 750 microliters of the test material are applied to the epithelial surface of the cornea. The test article is applied in a circular motion to ensure that the entire corneal surface is covered. The chamber can also be gently tapped to aid in spreading the test substance thoroughly. For dilutions that are not homogeneous suspensions, a positive displacement pipette tip can be cut and used for dosing to get the best sample. Once Nathan doses the first cornea, the timer is started and each chamber is dosed in succession, leaving sufficient time in between each chamber for the rinsing process. After dosing, the glass window is replaced on the anterior chamber to recreate a closed system, and the chambers are placed back in the incubator. Corneas are exposed to the solid test articles for 4 hours. After the incubation period, either 10 minutes for liquids or 4 hours for solids, the chambers are removed from the incubator. Approximately 1 minute prior to rinsing solids, the windows are removed. After completion of the 4-hour exposure time, each cornea is rinsed successively based on the intervals at which they were dosed. Nathan is using a syringe to add fresh EMEM with phenol red to the inside wall of the anterior chamber, creating a vortex and dumping the medium into a designated waste receptacle. Special care is taken not to spray the cornea directly with the medium. This process is repeated until most of the test material is removed. Then the anterior chamber is filled with EMEM containing phenol red before moving on to the next cornea. If residual test article still remains, a gentle stream of medium can be sprayed onto the cornea already containing media, or a cotton tip applicator can be used to aid in removing residual test article. Once each cornea is completely rinsed, the glass window and window locking ring is replaced. Particularly viscous liquids may be rinsed using this open chamber method as well. The rest of the rinsing continues following the closed chamber method. From this point forward, the rinsing process is the same for the liquids and viscous liquids and solids. Lindsay will demonstrate how to rinse using the closed chamber method. First, flip the chambers to a vertical position and remove the test article for liquids or the medium for solids from the anterior chamber through the holes at the top of the chamber. 2 to 3 milliliters of media containing phenol red are added through the holes to all the chambers. The chambers are inverted and the media is removed. This process is repeated at least 3 times. If the phenol red containing media is observed to be discolored, yellow, or purple, or if test substance is still visible, the corneas are washed until the media remains red and all test material has been removed from the cornea. Once the media is free of test material, a final rinse with EMEM without phenol red is performed to ensure the phenol red media is removed from the chamber. After rinsing is finished, the anterior chamber is refilled with fresh EMEM without phenol red and plugged. Corneas originally dosed with liquids are placed back in the incubator for an additional 2 hours at 32 degrees Celsius. Corneas treated with solids do not require a post-exposure incubation time. At the end of the post-exposure incubation step for liquid test articles, and directly after rinsing for solid test articles, the final opacity reading is taken for all corneas. Each cornea is observed visually, and notes on the appearance of the cornea are recorded, such as tissue peeling, residual test article, or small areas of defined opacity. The observations are important as they can be used to support opacity measurements. Once all opacity readings have been taken, the media is removed from both sides of the chamber, and only the posterior chamber will be refilled with fresh EMEM without phenol red. The anterior chamber is aspirated, and 1 milliliter of sodium fluorescein solution is added through the chamber holes and plugged. A 4 mg per milliliter solution of fluorescein is used for corneas treated with liquid test articles, and a 5 mg per milliliter solution of fluorescein is used for solid test articles. After adding the fluorescein solution, the chambers are flipped into a horizontal position and placed in the incubator for 90 minutes. Once the 90-minute incubation is complete, the media is removed from the posterior chamber of the cornea holders, and the optical density of the media is determined using a spectrophotometer or a 96-well microtiter plate reader. The value is recorded as the OD490 value, or the optical density at a wavelength of 490 nanometers. To calculate the opacity value for the test article, the net opacity is determined for each cornea by subtracting the initial opacity from the final opacity value. Then, the net opacity is corrected by subtracting the mean negative control net opacity, and the average corrected net opacity of each treatment group is calculated. For the permeability value calculation, the OD490 values are corrected by the mean negative control OD490, and the average corrected OD490 for each treatment group is calculated. Once the opacity and permeability values are determined, they are entered into an empirically derived formula to calculate an in vitro irritancy score for each treatment group. The opacity and permeability values can also be evaluated independently to gain additional insight on the irritancy of the test article. The in vitro irritancy scores may then be used to identify test chemicals that may induce serious eye damage, GHS Category 1, and chemicals that do not require classification for eye irritation, GHS No Category, according to the table. Laboratories initially establishing this test method for use in their facility should consult Annex 3 of the OECD test guideline for a list of proficiency chemicals. These chemicals can be used to demonstrate technical competence in the BCOP assay prior to submitting BCOP test method data for regulatory hazard classification purposes.